Good morning, students. Today we are going to discuss about Grignard reagent. So this is also called organometallic halide. This is also called organometallic halide. Why? Because R is an organic molecule like ethyl, methyl, propyl, butyl, something, or phenyl, something like that. And this is metallic. Magnesium is metal, and halide. X stands for what? Halide. This R can be methyl, ethyl, propyl, and everything, anything. Then H stands for what? Generally we take bromide, or sometimes we can take chlorine also. RMGCl or RMGBr also. How we can prepare it? Preparation. Let us suppose I take RBr, reacts with Mg and dry ether. Why we need to maintain dry ether conditions? Because magnesium is a second group metal. So if the moisture is there, it reacts violently. That's why we need to maintain dry conditions here. So here we'll get RMGBr. This is organometallic bromide, or alkyl magnesium bromide also we can take. Alkyl magnesium what? Bromide also we can say. Yes. So now we prepared this. What are these applications we will see. So here it is RMGBr, then we can easily see that the R will have the minus charge, Mg will get minus, plus, and Br will get minus charge, because magnesium being the electropositive will get the plus charge, then alkyl group will get the minus charge because it is attached to the magnesium. So this R minus can act as what? R minus can act as what? It can act as base also, and it can act as nucleophile also. So reactions due to basic strength. Reactions due to basic strength, or based on basic strength we can say. That means if you take RMGBr, acidic hydrogen containing compounds like acidic hydrogen, if you react with acidic hydrogen containing compounds, then what happens? R minus will take this H plus, becomes what? Alkane. What will get? Alkane will get, because R minus can be what? It can be methyl, ethyl, propyl, anything. If you take methyl magnesium bromide, we'll get methane. If you take ethyl magnesium bromide, we'll get ethane. But if you take phenyl magnesium bromide, we'll get benzene. If you take benzyl magnesium bromide, we'll get toluene. So whatever the group we have taken here, then with respect to alkane we'll get here. For example, we'll take the examples like C2H5. For example, C2H5 MgBr when reacts with simply H2O, acidic hydrogen containing compound, we'll get C2H6, and remaining will be MgOH and Br, like this. That means can I take the generalized reactions like when R MgBr when react with acidic hydrogen containing compounds like H2O, like some other alcohol like C2H5OH or phenol. These are all containing acidic hydrogens, isn't it? Or terminal alkynes, or we can say R-COOH, some carboxylic acid. We can take some. All these are having what? Acidic hydrogen. Or we can say amines. In all these cases, what we can expect is this R minus will take H plus from all this. These are all acidic hydrogen containing compounds. We have water, alcohol, phenol, then alkyne, carboxylic acid, amines. These are all what? They can provide H plus ion. If they can provide H plus ion, in all these cases, the common product is what? Alkane. For example, if we take phenyl magnesium bromide and reacts with some ethyl alcohol, like that, what we can expect here? We can expect, you may think that what may be the reaction happening, what will be the reaction, I never studied what is the reaction, then it is no problem. This is, what is my R minus here? That R minus is phenyl. The phenyl will take this H plus, it will simply become what? Benzene. And remaining will be Mg, OET, then this is Br. Because this phenyl will take this H plus, then Mg, O minus and Br will be on Mg, then we'll get what here? Here we'll get the benzene. This is many times the questions has been asked on this. Okay. So like this we can say the Grignard reagent as acid. Now we'll see reactions in which Grignard reagent acts as what? Nucleophile. Reactions as a nucleophile. Reactions as a nucleophile. Let us see. When Grignard reagent reacts with, first one, when Grignard reagent RMgBr reacts with formaldehyde, what you will get? Formaldehyde. So, and followed by hydrolysis, we will get primary alcohol. What is this? This is the primary alcohol. How we are getting this? Let us see the mechanism. So in the mechanism we can see clearly that, so RMgBr reacts with formaldehyde. This R minus as a nucleophile will attack on the carbonyl, because we know that the carbonyl compounds undergoes nucleophilic addition reactions. So in the nucleophilic addition reactions we can see that here R minus is not acting as the base. Why? Because in the formaldehyde there is no acidic hydrogen. It is a neutral molecule. Don't think that sir, though hydrogens are there, these two are acidic. No. The hydrogen attached to the carbon are not acidic. Hydrogen has to be attached with more alternative element. Then only we can say it is acidic in nature. Therefore, it is a perfectly neutral molecule. And also carbon having electropositivity, because carbon attached to what? Double bonded O, which is highly electronegative. Therefore, here the phenomenon is electromeric effect, because the shifting of pi bonds towards one of the bonded atoms due to the attack of the external reagent, we call it as what? Electromeric effect, which is a temporary effect because it operates only in the presence of external reagent. Therefore, as the reagent attacks on this, then what happens here? Then here it is OMgBr, and here it is R is there. Then second step what we did? So we did hydrolysis, isn't it? So when we do hydrolysis, then this is H and this is what? OH. Then what happens? We will get RCH2OH, and remaining will be MgOH. This nobody asks, this is the byproduct, that's all. So what they ask is what is the main product, but this is the main product. The main product is what? The primary alcohol, we can say. So students, can anybody say how I can prepare secondary alcohol and tertiary alcohol using the Grignard reagent? Yes, can anybody say? Tell me. By looking at this mechanism, we can easily able to guess how we can prepare the secondary and tertiary alcohols. Yes, tell me. Okay, let us see. So, if you want the secondary alcohol, what we do is, instead of formaldehyde, we take what? Instead of formaldehyde, we take aldehydes, other than the formaldehyde. When the Grignard reagent reacts, any other aldehyde other than formaldehyde, with the formaldehyde only we will get primary alcohol. Then if you take any aldehyde other than the formaldehyde, that is this aldehyde, then here we will get what you will get? Secondary alcohol, R-CH-OH, and this R will attack here, then this is definitely what we can say? Secondary alcohol, isn't it? Yes. So this same mechanism, the mechanism is as it is, like we can say this RMgBr will attack on aldehyde. This R minus is there, it will attack on this, and this will go like this. Then we can easily see that R dash CH, and this is what OMgBr, and this is R is attacked. Then what is the next step? The next step is hydrolysis. When we do hydrolysis here we will get H, and this is what? OH. Finally what we got? R dash CH R, and this is what? OH. And this is called the secondary alcohol. So secondary alcohol is prepared by this method. Okay. So then like this we can able to prepare secondary alcohol. Then if you want tertiary alcohol, then what we do is the Grignard reagent has to be reacted with what? Some ketones. Ketones. R dash R dash. If we react with ketones followed by hydrolysis, then we can easily say that here we'll get R minus will attach on this and this double bond will become OH. What is the shortcut method to write the product? Attack the R minus on the carbonyl and convert the double bond O to what? Alcohol. That is the shortcut way. So R minus is there. One more R from Grignard reagent attacked. Then this became what? Tertiary alcohol. Tertiary alcohol. So by this way, we can able to prepare primary, secondary, and tertiary alcohols using Grignard reagent. So we can do questions like just I took R and R dash and all these things. So we can take ethyl, methyl, benzyl, propanol, then propyl, any molecules we can take. They will ask the following secondary, primary, tertiary alcohols can be prepared by taking which of the Grignard reagent and which of the aldehyde or ketone or formaldehyde they will ask. We'll do the questions in the next class. Okay. Thank you.